The key is compared with which element first? Mid elements. Yes. So we need a lower bound and upper bound of the array, current array, to be considered. Initially, the whole array will be considered, and then mid is found, and we compare the key with mid, and depending on that, we decide whether we have to stop the searching if the comparison is complete. Okay, if key matches with mid, we return found flag or the position of mid, that is returned. If key is less than the mid, then we move to the left subarray and we search the key in that left subarray by finding mid again. Okay, so we can do this recursively as well as iteratively. And the condition is you need the sorted input. Okay, every time mid will be modified. So we have to handle the half of the inputs every time. I will open the program today in the uh, word editor, WordPad. The binary search. Here we will write the recursive, discuss the recursive code. So lower bound and higher bound, it is passed L and H. Initially it is 0 and n minus 1. Okay, and this is the key, which is a string. Okay, that's why it is character array. And this is our matrix of string. Matrix, because it is array of strings. That's why it is declared as a matrix. Okay. Yes. Binary search. So we have to be sure before we call the binary search function, we have to be sure that the array is sorted. Okay, then only. So we can ask the user to be sure that the array is sorted, so that he will call first the sorting function and then call the binary search case. Okay. So first we will become sure. Otherwise, there is you can call here directly the sorting function also, and then you can go for the binary search. Okay, then the key is taken from the user, and that key is passed here to the binary search function. Our array, the key, and the 0 to n minus bound that is passed. Okay, and if it returns -1, the function return -1, then it is not found. Otherwise, the location will be displayed. Okay. So binary search recursive. We have discussed actually this algorithm in the theory session. So here we will be first checking whether low is greater than high or not. So that means when low becomes greater than high, that means the division is not possible. Further division is not possible. That's why it will return not found flag. Okay. Otherwise, we will be finding mid. Okay. If low is less than or equal to high, then we will find mid of it, and then we will compare first with that mid. The key will be compared with the mid. Okay. Here we will be using string compare function for comparison. The key and the middle element will be compared. So comparison returns 0 if the key is matching. Okay. If these two strings are equal, then it will return 0. So we will return the position of mid in that case. Otherwise, if it is not matching with the middle element, then we will be deciding to search in the left or right subarray. Okay. So if key is greater than middle element, then we will be searching in the right subarray. Okay. So this is the condition for first string is greater than second string, okay, then it will return greater than 0 value, positive value. So key is greater than string of mid, then we will search in the right sub array. That's why the bound will be modified to mid plus 1 to high. Okay, our lower bound will be shifted to mid plus 1. So we will consider half of the array only in the next recursive call. Okay. Otherwise, if it is not equal to 0, not greater than 0, then that means it is less than 0. So it will return it will again call binary search, and now the upper bound will be modified to mid minus 1. So we will search in the left sub array in that case. Okay. So this will continue until either match is found. Okay, either we reach this condition, match is found, or the division is not possible. These are the two base cases to stop the recursion. Okay. Any problem with the binary search recursive? Code blocks is working now. We will discuss that. Any doubt in the binary search recursive? Then we'll see the iterative. In iterative also same logic is there, but we will be using a while loop. So binary search iterative we will see here in this program with records. Okay, sorting with records. Okay, here again, see we are passing the array of records. So instead of this, we will pass array of strings. Then the key, this is the key, and the total number of elements. Okay, these are the three parameters in the iterative. There is no lower bound, upper bound pass, because it will not be modifying. We are going to call this binary search only once. But in the recursive case, we are calling the binary search function multiple times recursively with the modified input to be considered. That's why we were passing lower and upper bounds. Okay, here we are only passing n. Now this I is 0 and j is n minus 1. These are the lower and upper bounds to be considered initially. Okay, and while I is less than or equal to j, find the middle element. Okay, so same thing, but we are now using while loop. First of all, we will find middle element. No need of counting comparison. Then we are comparing first with the middle element. Okay, mobile number is compared. This key is compared with the middle element. If the match is found, then we can return the position of that mid. Return k. Otherwise, if the key is greater than the middle key, then we are moving to left subarray. So, can you tell why we are moving to the left subarray here in this case if key is greater? Can you predict? Key greater hai to it should move to the right subarray, but here it is moving to the left subarray. Why? The array is in descending order, correct. So, as here our array is in descending order, that's why we are searching. If the key is greater than mid, we will be searching to the left. Okay, we will be modifying our upper bound. Okay, but if it is in ascending order, you have to exchange these conditions. Okay, you will be modifying the lower bound. Okay, and so these are the three cases कि equal to की है, less than की है, greater than की है. Okay, otherwise this loop will stop whenever there is no further division possible. Okay, the loop will stop and we will be returning -1 flag, not found. Okay, after this while loop ends, otherwise यही से return हो जाएगा. If the match is there, it will get returned from the this position only. Yeah, otherwise यहाँ से कहीं से return नहीं हुआ तो it will come here and it will return -1. Okay, this is binary search iterative. So with this we have completed our discussion of the fifth assignment. Okay. Any doubt in these first five assignments? Shall we start discussion of the next assignment? Merge sort.
Okay.
So merge sort is to be performed on numbers. Okay, so we have already written the functions for it. Okay, accept display function is there in the first assignment. Set के साथ जो accept display किया है वही यहाँ पे भी use करो. Okay, so because we have to arrange the numbers only. I have not created lab assignment 5. I will create it on the Google Classroom. And in the next week, you are supposed to submit this fifth assignment also. Do the multiple practice with different types of inputs on all these algorithms. So for the merge sort, we will first read that assignment. So we have to implement merge sort and quick sort algorithms both in this program. Okay, and it is told that recursively and iteratively. So merge sort, we will see both recursive and iterative functions for it, and quick sort recursive we will discuss. So these three algorithms you have to implement in the sixth assignment. Okay. Merge sort program is visible to you?
Yes, ma'am.
So here array of integers is taken. Okay. Accept display function is similar to our set assignment, simple array. Then we are supposed to arrange in ascending order using merge sort. So this is a recursive program where recursive function where we are passing both lower and upper bound. Okay. And again calling display. And in iterative, we are just passing the array and dimension. Okay, we are not passing the bounds. So we will discuss first the recursive algorithm. I have also already discussed in the class yesterday. So in merge sort recursive, here again we have to divide the array into exact half. Okay, that's why mid equal to low plus high divided by 2. But in binary search, we are dividing in three parts: middle element, less than middle, and greater than middle. Whereas in merge sort, we are going to consider the elements from low to mid in one partition and mid plus 1 to high in another partition. Okay. So this is our, so only two partitions we are going to consider, not three, like in binary search. Okay. So here again, after finding mid, we are calling merge sort again on the first half and merge sort again on the second half. Okay, so this will be completing our divide step. These two recursive calls will be dividing the array into half, half, half every time in the every recursive call. Okay, and after that, after the division is complete, that is, there is no element. Okay, this condition is false, then merge function will be called. Okay, when merge sort recursive, this recursive call is over, we reach the base condition, and its right part also, that is also not able to be divided, then that is single elements are remaining, then we start merging. Okay, so merging will be done on the left and right sub array. Clear? So division step, for division step we are calling this recursively the same function merge sort with different bounds. Okay, half bounds. And after the division is over, we start conquering. Okay, so conquering step, it is executed in the exactly reverse manner, like the recursion. Okay, to complete the recursion. So finally merging will take place on the uh, initial division. Okay. So we'll go to the example which we discussed during the class also. I will share the screen. Yes, so like we discussed, this is our first step of, initially when we are calling merge sort, it is called on this particular thing 0 to 11. This is the bound which will be considered. And after that, it will call merge sort. It will divide the array into 0 to 5 and 6 to 11. Okay, because 5 will be the mid, 0 plus 11 by 2, that was 5 will be the mid, so 0 to mid and mid plus 1 to high. Okay, so it will call merge sort first on this part. Okay, then it will call merge sort on this part, it will call merge sort on this part. So now this recursive call will be over. Okay, and then it will call merge sort on the recent right part. So right is this. Okay, on this it will call the merge sort. समझ में आ रहा है रिकर्सिव कॉल्स कैसे होंगे? इनिशियली इट विल कॉल merge sort on this, then merge sort on its left, then merge sort on its left. Okay, now the base condition is reached, so this cannot be divided further, so next call will be the right of the recent, that is this one. इस पे merge sort call होगा. When this is also over, then merging will take place on these two parts. Okay, that is concatenation of these two parts will be done. This will be done. Okay, समझ में आ रहा है? तो ये लेफ्ट पहले पूरा प्रोसेस हो जाएगा. This left will be processed first. Okay, and then it will move to the recent right. तो ये पहले डिवीजन 4 का ये स्टेप कंप्लीट होगा, एंड देन इट विल कंप्लीट दिस लाइक दैट. ओके, सो ये पहले कॉन्करेशन हो जाएगा, एंड देन इट विल गो टू द राइट ऑफ दिस, एंड इसका फिर से लेफ्ट 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 होगा until single element remains. Single element remain हो गया तो it will start, it will call merge sort on its right, recent right, then it will go to the previous call like that. So completion of the pending calls is done in exactly reverse order. Okay, पहले calling होता है, then completion होता है. Okay, समझ में आ रहा है? So this is somewhat you have to understand how this completion will take place. Okay, so first division will take place and then concatenation step. In concatenation, we have to follow the algorithm for merging two sorted arrays. Okay, merging of two sorted arrays, that will be done on this input first. Okay, the recent call is this 13, 15, that way. Then merging will be done on these three, then 6, like that. Okay, and merging के लिए हमने कौन सा algorithm follow किया है? Merging of two sorted arrays. Okay, in which we have to do the comparison of, so suppose we have considered this as inputs, two sorted arrays, तो हमको merge करने हैं. These are the two sorted arrays which we have to merge at this time. This is ith element, this is jth element. Okay, and this is k, which is initially 0. I, this is I, this is j, and this is index k. Okay, so merge करके हम एक temporary array में store कर रहे हैं. And we can, so this is our part of original array. Okay, हमारे original array के ही ये parts है. So what we will do, we will compare ith element of this, it is 5, with this element 10. Whichever is less, we will copy it here. Then I will be incremented. In this case, I is less, ith element is less. That's why it will be copied here, and I will be incremented and k will be incremented. K will also increment. Okay. Then again, I and jth element will be compared. Now jth element is less, so that will be copied here, and j will be incremented, k will be incremented. Okay, k will be now pointing this way. Then comparison is done with this I and this j. The ith element is less now. Okay, that will get copy here 17, and then k will be modified, I will be modified. Again, ith element and jth element is compared. Now jth element is less, so that will be copied here at kth position. Then k will be modified, and I will be, sorry, j will be modified. Okay. Again, this see, we have completed the second array, processing of second array. So remaining elements of this will be copied as it is. 33 will be copied as it is without comparing with anyone. Okay. So like this, our temporary array is there, which has stored the both sorted arrays combined. Okay. After these sorted arrays are combined with each other, we will get another sorted array. And this we have to shift as it is to the positions from where we have taken it, from 6 to 11. Okay, ये 6 to 11th position के elements है हमारे original array के. That's why we will shift it as it is here in 6 to 11. The same positions. Okay, but in the sorted way. This is how the merging will take place, and the sorting is done during merging. Okay, or during concatenation step. Okay, so we have seen this logic, and we will write the function in the same way. So in this merging step, we have the logic for sorting. And merging क्या करेगा? Merging will merge two sorted parts. Okay, so here we are passing complete array, and उसमें से कुछ भी जो parts है हमारे divide किए हुए, we will do the merging on that. Okay, so this function is important. Merging of two sorted arrays. L1 to U1 is the first array, and L2 to U2 is the next sub array, which we have to merge. Okay, so I is L1, J is L2, while I is less than or equal to U1, and j is less than or u2. ओके, सो इन दोनों में से कोई भी एरे पहले ओवर हो जाएगा, then this loop will stop, while loop will stop, because there will not be any comparison. Okay, comparison के लिए कुछ एलिमेंट ही नहीं बचेगा. That's why this loop will continue until one of the array is over. Okay, so L1 से start किए दोनों arrays. I is pointing first sub array and j is pointing second sub array, and both these are parts of the same array A. Okay, same array A के ही दो parts है, L1 to U1 and L2 to U2. Okay, and we are processing both the sub arrays. We want to merge them. Okay, and both L1 to U1 is also sorted and L2 to U2 is also sorted, and we want to merge them. Okay, so we will compare A of I with A of j, and whichever is less, we will copy that into the temporary array. Okay, at kth position, k is starting from 0. k array में हम store कर रहे हैं वो जो भी lesser element है वो, and we are modifying k as well as I. Then otherwise, if A of I is greater, then A of j will be copied. Okay, and k is incremented, j is incremented in that case. तो ये while loop क्या करेगा, जब तक दोनों arrays में elements है तब तक it will compare and it will copy the lesser element. But one of the array is over, then we have to copy the remaining element of another array. So until I reaches to U1, copy the remaining elements of first array as it is into the temporary. Or if ये loop over हो गया है I का and j is still remaining, then this while will execute. While j is less than or equal to U2, copy remaining elements of second subarray as it. Okay, so ये temp हमारा create हो जाएगा which is sorted. Okay, and which is having elements from both the subarrays. Okay, so ये concurrency step हमारा over हो गया, but now the resultant elements are still in temporary. We have to shift them back to the L1 to U2 positions in our own array. Okay, data array जो है हमारा उसमें हमको वो shift करना है. That's why this loop is there. Okay, so j is starting from L1 to U2. J is starting from L1 to U2. At that position A of j, we are copying all the elements from temp of I. Okay, and I is running from 0 to till all the elements we get copy. So this one condition is sufficient for that. Okay, so we are copying all the elements from temporary array to our original array where we have all the elements. Okay, and then we have to display passwise. That's why after every partition step, this concurrency step is over, we will be displaying the output. After every concurrency step, we are displaying the output of that L1 to U2. That sub array only we are displaying, the one which we have conquered. Okay, this is mod sort. I will try to execute it. I have not tried in the code blocks. Share the output screen. Okay, first is add elements. So I will take more number of elements so that division and concurrency is clear to you, and the testing of your algorithm will also be done properly. Less number of elements पे लो के 4-5 elements पे, so division will not take place, and you will not also come to know कि properly हो रहे कि नहीं सारे steps. So more than 10 elements पे आपको test करना है. I will enter data 45, 23, 11, 19, then 22, 44, 55, 56, 59, 58, 42, 21. So these are the elements to be sorted. Now, the recursive merge sort I will call. Okay. So see the steps. Sorted subarray. पहले like I said you that left process होगा and these two will get sorted first. Okay, concurrency on these two elements will be done first. Then next, this is the subarray. Okay, these three elements. That's why 11, 23, 11, 23 and 45. These will be first conquered. First three elements. Okay, पहले दो elements, then first three elements will be conquered. Then 19, 22. These elements will be conquered, and then these five elements will get together. Okay, like this. ठीक है, क्योंकि ये तीन हो जाएंगे, ये तीन हो जाएंगे डिवाइड. Then again the division will be on one and two elements, like that. ठीक है, concurrency will be done in exactly reverse order. And then this is for right. Right का भी left most का पहले होता है concurrency, then these three elements will be conquered like that. Okay. Any doubt? Yes, any doubt? This is the sixth assignment. So I will create the assignments, both fifth and sixth assignments on the Google Classroom, and I'll give the deadlines in the next weekend. Okay, for both the assignments. So you will get one complete और merge sort के लिए उसका आगे का week देती हूँ. Okay, so that you will get good time, because quick sort also to be added in that same assignment of merge sort, and we have to yet discuss quick sort. तो अगर कुछ डाउट है तो पूछो.